الحمد لله رب العالمين.
Alright, okay, let's continue our class. So, Hazimah ada cakap tadi yang katanya kita tertinggal redox titration, right?
Yes,
Okay. And to be specific, what kind of redox titration yang kita tertinggal sebenarnya? Is it Winkler method? Okay, so kita continue dengan Winkler method. And I noticed that when you talk about the redox titration ni kan, baru saya teringat tentang Winkler method tu. Malam, okay, I'm sharing with you a very simple slide. Okay, the Winkler method is a very simple topic. Okay. In chemistry, we using the one of the technique can be used to determine the water quality is by using Winkler method, and this Winkler method we use to determine the dissolved oxygen in order to determine the biological oxygen demand. So as we know, the water that we drink tu kan, so air tu walaupun dia colourless tak nampak apa-apa, but it has their own quality yang we have to analyze and we have to study. Siapa pernah minum air, for example, air sungai, rasa dia lain sikit, and then air laut, salty, and then if you drink air zam-zam, and then dia rasa macam pahit-pahit sikit kan, sort of macam tu. So this qualitative indicator tell us that the water has their own quality. So in general, one of the quality of water that can be tested adalah oxygen dissolved ataupun BOD, inilah yang kita nak kaji. Why we have to study the oxygen dissolved? Right. Long time ago when I was young, so I believe that fish dalam pond ke, in the lake ke, or in the sea ke, ocean mana ke, in aquarium for example, I believe that the fish going what you call it, doing his respiration by guna air tau, but actually that is wrong. Actually fish bernafas, breath by using oxygen as well, oxygen dalam air tu. So masa saya kecil dulu lah, budak-budak dulu kan, dan satu tu, so that is my first thought. So when I realised that oxygen actually contained in the water, then barulah saya faham. Okay, so this is application. Why we must, kalau saya why we must learn this topic. Jadi kemestian kita kerana we want to make sure that our environment safe and then we can protect our environment. When you see pond, for example, that pond ke mana-mana lake ke, and then there are a lot of alga kat atas tu, alga tu. So we can use this alga bloom as an indicator to determine the health of the lake ataupun pond system tu. So alga ni macam indicator lah, the more alga that can be found bermaksud the lake ataupun pond tu high pollution. So this is process in general. So nitrogen loading masuk dalam ni, and then as we know alga is a plant, then dia akan keep growth because of this nitrogen, and then selain daripada nitrogen loading, the death body of the aquatic living macam fish ke apa-apa ke, crustacean ke, apa sahaja yang duduk dalam air tu mati and then dia decompose, also can be a food to the algae. So algae tu boleh growth and dia akan jadi bloom. So as we know, algae ni dia macam-macam colour ada blue, green kan. So this algae is very dangerous. Not very lah. It's a dangerous because the waste produced from the process the algae do adalah toxic kan, toxic. So it's not safe to the human as well to drink the water. Macam tu. So kalau awak pergi mana-mana tempat, pergi mana-mana tasik terbiar ke, then you can see that so the algae is so thick, for example, kat surface of water tu, then janganlah minum air tasik. Okay, ini proses IB won't ask you tapi saya saja sampai tahu. Okay, causes, kenapa berlaku benda-benda ni, kenapa berlaku? Ataupun for example, eutrophication process occur. You guys bio student kan, so mesti tahu punya. Kenapa benda ni berlaku? Because of what? Anyone? Volunteer?
Teacher, I volunteer.
Yeah, go ahead.
Eutrophication happens when there is like the river near a farm. When the farm use some kind of fertilizer that contains nitrogen or the waste product from animals like cow, most of the waste product contains nitrogen, and when it rains, this excess nitrate and phosphate will flow down into the river, and this will cause like the nitrate and the phosphate will become some kind of nutrient for the algae, and then the algae will undergo growth rapidly, and then the algae will float onto the surface of the water, preventing sunlight from going into the river. And then when this happens, the plant inside the river could not produce oxygen for the fish. And then because there is no oxygen, the fish will die inside it, and the dead body of the fish will decompose and contribute also to the nutrient for the algae and some microorganism.
Alright, very good explanation. Siapa tu, Haziq eh?
Yes, sir.
Okay, so I still recognize your voice. Alright, so good explanation by Haziq. Well done. It is because of tangan-tangan kita. Contohnya dia bagi tahu kat sini. Waste product from the agriculture ke ataupun pieces from cow or apa-apa sahajalah yang contribute to the nutrient to the algae, and then algae grow. I love the word. He used grow rapidly, so you increase dia punya rate, and dia akan, it's a kind of layer kat atas water surface to prevent from the sunlight heat to the ground. Tak boleh nak undergo our photosynthesis, and then the fish suffocate of oxygen, then dia akan die. Okay. Well done, Haziq. So that is the process of the eutrophication. So basically, let's talk about a system. When we talk about the system macam river ke pond ke, if we disturb the system tu, dia akan jadi imbalance. Right? So the keyword here is an imbalance of ecosystem. So actually, let's say you have two fish, you have two panggil tumbuhan dalam laut tu kan, apa-apa plant lah yang boleh produce oxygen. So both of them tu require need each other lah. So the plant will produce oxygen and the fish can breathe using that oxygen. But if the plant die, so fish no oxygen, so fish won't die. So dia jadi imbalance. So whatever system it is kan, so even the lake ke, river ke, our earth, our environment, even ourself pun kalau berlaku imbalance, kita akan destroy ataupun something not good will happen. So moral of the story, make your life balance. Kalau anak study kena balance, kalau anak makan kena balance. If you eat imbalance, hari-hari makan Starbucks, then at the end of the day awak akan jadi obese. So IB learner profile lah, balance tu. Okay. Alright, this is BOD, biological oxygen demand. So BOD and DO is two different things. Dissolved oxygen is something yang we measure the oxygen. BOD, we measure how much oxygen used in that system lah. So dia vice versa lah sepatutnya. So kalau you have a very high concentration of oxygen, so meaning that BOD is small. So the river ataupun the pond tu akan kita panggil sebagai healthy pond lah, ataupun healthy river. So dia tak ada less pollution. But if the oxygen concentration is very small, and then BOD is very big, indicate that demand of oxygen is very high. Oxygen supply is ataupun oxygen dissolve tu sangat sedikit. So kita boleh cakap that system ataupun tasik apa-apa ke, very high pollution. So dia punya correlation lah. So how to measure the BOD? So in order to measure BOD ataupun we talk about the dissolved oxygen, kita pakai Winkler method. So this is a Winkler method. So the Winkler method is about with objective dia adalah, so we want to find the ratio between the oxygen and also the iodide. Why oxygen and iodide? Because at the end of the day kita akan titrate this iodine and also thiosulfate, and then you get the iodide. So at first place, so Mn ataupun manganese sulfate kita panggil. So the manganese sulfate we dissolve in the alkaline solution. Okay, and alkaline. So we have to add some alkaline to it, and then you can produce manganese oxide. So the manganese oxide kita akan dissolve again in acidic. So at first the dissolve in alkali, the second one we dissolve in acid. What purpose here? To get this iodine. So therefore iodide itu akan oxidize and then form iodine. And then the last one, when you have this iodine, this is very orang panggil convenient ataupun powerful, not powerful lah kot kan. So easy to use lah. Okay, easy to use to measure the concentration by titrate dengan thiosulfate. So this is common lah, banyak titration tu buat macam ni kalau we want to measure secara backward from back titration. So what you get is the sulfur akan oxidize and then the iodine akan reduce. So 1, 2 and 3, these three equation must, okay, you have to memorize it ataupun you have to understand it, right? You have to memorize. Kalau tak nak memorize, faham lah. But if you faham, then I don't think you have to memorize it anymore, because you know at first place Mn2 plus akan akan oxidize and then jadi Mn plus 4. So this is plus 2. So the oxygen akan reduce jadi minus 2, for example. So next part is after the manganese oxidize, and then dia akan jadi reduce balik. Why? Because we want to get this iodine, sorry. So at the end of the day, we have to work backward balik. So you have to find the ratio. Yang penting ratio and also the process lah. This is oxidation. This is oxidation. And then this is reduction. And then this is -1 and then become 0. So this is oxidation. You have to know the ratio. Itu yang paling penting sekali. So you have to look at dia punya ratio kat sini. Oksigen berapa ratio dia dengan manganese? 1 to 2. And then manganese and iodide is 1 and 1. Right. And then this is 2 and then this is 1. Cuba masuk berapa oksigen kita perlu. 1, 2. 1, 1. So this is 1 and then this is 2. So this is 2. So the ratio is 1:4. So number of mole for iodine and then number of mole for oxygen is 4 ratio. If you have 1 mole of iodine, therefore the system have 4 mole of oxygen. That is the dissolved oxygen. Habis je lah pasal Winkler method. So these three type of equations ni wajib hafal, wajib faham. And then kalau awak mungkin awak stuck somewhere ke macam tak nampak macam mana ni post ni 1 ni 2. And then here we use 1 1. So what is dia punya ratio dia? Alright. Ada soalan nak tanya? This part kan yang kita tertinggal ke?
Betul, sir.
So, any more question?
So macam tak nampak lagi yang ratio tu.
Sorry. Sekejap Saya terbalik, sorry. This is 1 mole of oxygen and then this is 4 mole of iodine. Sorry. 4 mole of iodine.
Sir, kalau nak
Sekarang?
minta sir macam yang sir explain balik yang ratio tu boleh sir? Tadi macam laju sangat.
Okay, saya slow down kan ratio Saya terbalik. Look at the first stage. Okay, the first stage here, we have to ignore ni lah sebab ni tak ada apa pun. So, kita tengok sebab the second equation, why we consider this one, sebab second equation kita pakai manganese. Right? So kita pakai manganese. Sorry, this is not iodine, this is thiosulfate. Confused tu saya. I'm confused lah. Tertukar. Alright. So what is the ratio for the first equation? We have to look at these two sahaja. 1 and 2. Okay, clear. Simple lah kan? So just ignore water apa semua ni tak perlu. This is only for balance. So the second equation, when you react the manganese oxide dengan acidic solution and the azide solution ni to get the iodine, look at the ratio. Manganese oxide and also iodine. So the ratio is 1 and 1. Betul tak? But when you look at the last one, because ni yang penting, we titrate. This is redox titration. We titrate. What does it mean by redox titration at first place? So redox titration is it's a titration technique we use and we determine dia punya endpoint when the different oxidation ataupun the number of oxidation for an atom tu berubah. So dia reach the punya endpoint. So the last equation, if you see carefully, what is the ratio between thiosulfate and also iodine? This is 2 and then this is 1. Right. So equation 3 ni dia bukannya separate tau. It is not separate. Dia adalah berkait daripada sini, dia berkait kat sini. And then this is occurs at one system. In the, let's say kita panggil sebagai dalam botol ni. So this is what happened. So at the end of the day, in order to determine the oxygen concentration ni, we have to kaitkan balik at the previous equation and previous one. So seen here we have 2 thiosulfate. And then this is 1. So bermaksud thiosulfate and manganese 1 to 1. Tapi manganese and oxygen, manganese is 2. So actually this is 2. So bermaksud kat sini the 2 ratio ni when we compare ataupun kita correlatekan dia, actually dia adalah 4 thiosulfate and then oxygen adalah 1 mole. 2 ni. Kalau ratio between iodine dengan thiosulfate is 1:2, right? But this thiosulfate ni carry berapa banyak dia punya, kalau 1 dah 2, kalau 2 dah 4 contohnya. This is the ratio dia. Tapi this one is derived from the first equation. So the ratio at first is 1:2. Alright. Faham ke? Confused? Faham Okay, so nanti soalan tanya apa actually? Dia tanya ratio je. What is the ratio between oxygen and thiosulfate? So the ratio is 1:4. Okay, let's find the soalan. Soalan dia akan tanya, the soalan will, okay, the question akan tanya korang tentang kefahaman ni je, n equal to mv over 1000. Ini je yang dia akan tanya. When you talk about redox titration, it's just like macam korang titrate biasa sahaja. Cuma the process is different in the way macam this one changes of the oxidation number. Yang traditional titration ataupun the normal one we determine by using the color change, color of indicator kan. Tapi ni tak. But the whole story here is at the end of the day, ini yang penting. Okay, mungkin tak apa nak nampak, tak apa. Let's see the IB question bank. So where is my IB question bank? Nampak ke? Ke saya tak share?
Saya tak share lagi.
Oh, alright, sorry. Okay, I'm sharing my screen now. Okay, let's find. Incremental is SL. Dia hanya tanya macam tu je. Apa mungkin? What is the ratio of oxygen to the thiosulfate in the Winkler method? So jawapan dia adalah 1:4. 1 mole oxygen, 4 mole of thiosulfate. Let's find question. So tak ada soalan implemented so far. Dalam tag, okay, kita tengok dalam handbook lah. Okay, dalam handbook. Let's look at the handbook. Mungkin dalam handbook ada soalan tentang wrinkle method. Ataupun not mistaken ada dalam okay, let's look at this question from this video. Yeah, remember someone nak share ni. Okay, soalan akan tanya macam ni saja. 500 cm cube of water react with magnesium sulfate in a basic solution. Ayat-ayat ni mungkin nampak macam apa ni tak tahu kan. Actually this first equation tadi. So if you understand the process, or at first place we add the alkaline, then next we add the acidified potassium. What's required to react with? So calculate the dissolved oxygen content of the water. Okay, let's do it together. Can you see my whiteboard?
Not yet.
Not yet. Okay, sharing screen again. Okay, now can you see my whiteboard?
Nampak?
Nampak kan? Okay, so 500 cm cube of sample water was react. Okay, so the sample dia adalah 500 cm cube. Blah, 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 blah. And then 12.5 of the thing was required to react with the with the iodine produced. What is the DO content of the water? So maksud dia kata what is the oxygen concentration? And then basically, okay, before I forgot, the dissolved oxygen dia punya unit basically milligram over PM cube ataupun terpanggil sebagai part per million. So first step is you calculate the mole of Na2S2O3, sodium thiosulfate. Actually dia adalah thiosulfate. This one. So this is yang kita kena. Okay, at first place you must write down the equation ni. So kena write down the equation baru awak tahu. So can you find the number of mole of thiosulfate? You have to press your calculator. You have your calculator and then let's press together. Okay, lepas kau dah dapat the number of mole, and then refer to the equation yang tadi, yang tadi tu. Okay. It's a 2S2O3 plus I2, then kau akan dapat punya produk. So the ratio is 1 and 2. So what is the number of mole for thiosulfate? And then what is the number of mole for iodine? So if you get the number of mole for thiosulfate, so what is the number of mole for oxygen? So the ratio is 1 to 4 kan. So in your opinion, press your calculator and then try to find the answer. But again, the dissolved oxygen milligram per dm cube. So here I'm trying to say that the next is once you get the mole of the sulfate, and then you have to find the mole of oxygen. Okay, this is very crucial part. After you get the mole of oxygen, you have to find the mass. So the mass must be in the milligram. So the mass milligram, and then the dissolved oxygen content is milligram over 500 cm. Okay, ini dia punya step. Let's see dia punya calculation.
Saya tak dengar suara.
Dengar suara. Okay, I think you will hear the voice now.
So using the equation N equals CV, we multiply the concentration by the volume in decimeters cubed,
I think you know how to find the mole kan?
which gives us 6.25 times 10 to the negative 4 moles of thiosulfate ions. Previously, we saw that the ratio of oxygen to thiosulfate ions was 1 to 4. So to find the number,
Okay, this is our second step. Once you get the number of mole for thiosulfate, and then you know from the equation to 1 tadi tu, and then previous, and at the end of the day, the ratio is 1 to 4. Bagi je lah.
number of moles of oxygen, we divide our number of moles of thiosulfate ions by 4, which gives us 1.56 times 10 to the negative 4 moles of oxygen. Next, we will calculate the concentration of dissolved oxygen in moles per decimeter, using the equation C equals N over V, where N is the amount in moles of oxygen and V is the volume of water in decimeters cubed. This gives us a concentration of 3.12 times 10 to the negative 4 moles per decimeter. Next, we will calculate the concentration of dissolved oxygen in grams per decimeter. To do this, we need to convert from moles to grams. So we multiply the amount in moles of oxygen by the molar mass of oxygen. Next, we multiply this mass by 2 because our original water sample was only 500 centimeters cubed. And finally, we'll calculate the concentration of dissolved oxygen in parts per million. 1 ppm is equal to 1 milligram per decimeter cubed. Therefore,
Okay, sampai sini faham tak? This is simple calculation kan? So you find the number of mole, and then you ratiokan dia dengan oxygen. So you can find the concentration, and then when you want to talk about the dissolved oxygen content, make sure you convert to the gram over dm cube. So dm cube ni must be enough 1 dm cube lah kan, so dia darab 2 tadi tu. So
9.98 times 10 to the negative 3 grams per decimeter is equal to 9.98 parts per million.
okay, macam tu sahaja.
Yang concentration tu kita tak guna pun.
Yes, concentration dia kita tak guna, tapi you just nak tunjuk. Sometimes the question can ask you macam-macam kan. Maybe dia can tanya what is the concentration of oxygen, So, kalau dia punya concentration of oxygen, this is how we show the working lah. And then if the question asks you calculate the dissolved oxygen content, I try to find the question about this tadi tapi macam tak jumpa. So ingat saya pernah sekali
12.50 centimeters cubed.
satu masa saya marking, the student dia hanya stop sampai dekat sini sahaja. Tapi the question, final answer dia nak dissolve oxygen. So what happen is you have to convert into gram, right? So you have to convert into gram by darab dengan molar mass and then divide by 1000 ataupun dia punya ni lah, dia punya apa ya, concentration dia tu, dia mesti dalam 1000. Tadi kita pakai 500 kan, is 500, so make it 1 dm cube. So 1 dm cube you have to times 2. Korang akan dapat this is the answer. Alright. Ada soalan lagi nak tanya? Macam ni je pasal Wrinkler method. So yang paling penting, you understand this equation and the process. Okay, if I ask you, can you balance the redox equation, boleh balance ke? Do you know how to balance the redox ataupun the equation yang tambah air, tambah asid semua tu? Pernah belajar ke?
Pernah tapi lupa.
Pernah tapi lupa kan. So if you want to balance the redox equation, so you have to split into two, oxidation and reduction. So at first place you balance the atom. So orang pernah belajar kan? Okay. So kalau pernah belajar, itu je lah pasal redox titration. We have 2 more minutes. Let's see. Okay, tak apa. I think tak sempat pun lagi 2 minit cari soalan. Kalau saya cari jumpa tak ada hasil juga because dah habis kelas kan. So tomorrow class, so lepas ni saya akan collect some of the question and then tomorrow class kita akan continue dengan soalan pasal redox titration ni. Tapi saya akan conduct lah, so you don't have to listen ke apa. I try to compile the question and then kita akan tengok 3 ataupun 4, 5 soalan for tomorrow. So to wrap up for lesson today, make sure you know the 3 equations in the Wrinkler method. Tu wajib tahu. Next, make sure you know that the ratio between oxygen and thiosulfate. Oxygen and thiosulfate, the ratio is 1 oxygen, 4 thiosulfate. And then lastly, make sure that you know when you talk about your dissolved oxygen content, you have to write in the gram per dm cube. So you basically macam saya cakap tadi aja guna M equal to MV over 1000. Okay. So apa, esok kita sambung lagi. Esok saya akan conduct class. Right, thank you for your attention and have a nice day. See you tomorrow. Bye bye.